Hey everyone, good morning, good afternoon, good evening from wherever you're joining us. Welcome, and we are so excited to have you today. We're excited to dive into the evolving landscape of multimodal data in life sciences. This is a space that's critical to drug discovery and development. And as many of you know, large-scale multimodal data that includes omics data has become a very powerful tool in research. And it's changing the way we approach everything from data integration to collaboration across teams. So as we look into 2025, many organizations in biopharma world, and maybe even yours, are asking that how can we effectively plan and budget for the technology that allow us to keep pace with the rapid advances in AI and machine learning? How do we use all of our data effectively? And how do we build a platform that aligns with fair principles to maximize long-term value of all of the data? So, if you're here today, you're likely grappling with some of these questions, and you're certainly not alone. Our goal is to help you navigate these challenges. With us today is Seth Shelnut, Chief Technology Officer at TileDB, who brings a wealth of knowledge on building scalable, future-proof data infrastructures for biopharma teams. Seth will walk us today through key evaluation criteria for selecting a multimodal data platform that can scale with your team's needs, from researchers to informatics and machine learning teams. Just a couple logistical items during the webinar. Please drop your questions into the Q&A panel, and we'll either answer them right over there or live at the end. Also, we have something on offer for everyone who stays until the end of the talk. So without further ado, I'll hand it over to Seth to lead us through today's talk. Seth, the floor is yours.
Thank you, Davika. I appreciate the introduction here. Today, we're going to be talking about how to choose the right multimodal data platform. Today's Halloween also, which I know picking a bunch of software can be scary at times. So I think it's very timely that we're doing this today. Also, it's budget season, which is also another scary time. So we're here to kind of help you guide through everything and hopefully come up with some criteria where you can evaluate the different softwares and vendors that you're looking at to be successful in 2025 and beyond as you pick the software. So some important aspects to get started with here are that scientific discovery is challenging. It's very expensive and it's inefficient, right? The amount of money that is spent here, the market cost of a drug is $2.9 billion. This is a significant amount of money, and it takes 10 to 15 years. These are long-term investments. And majority of your efforts in drug discovery don't yield positive outcomes. So there's two ways to understand though why this happens. It pays to innovate. There's a lot of money and time put in here, but you can have up to 10 times the amount of return when a new drug comes on the market. So it is imperative that you find ways to drive this forward. And the speed which you drive this matters a lot. If it takes 10 to 15 years on average, you need to be working faster and harder because all of your competitors are working on that timeline. And a delay of a year can be detrimental because that can take you from being the primary driver and discover to second place after a patent has been established and the work yields nothing. So it is a competitive advantage that you're able to move fast and move efficiently. All of this is powered by multi-omics and multimodal data, right? Being able to do this scientific discovery, it requires you to bring a diverse set of data into the ecosystem and into your data platforms and into the hands of your scientists that are trying to work here. This fosters a huge competitive advantage. The more data that you can bring in, the more diverse types of data that you can bring, the more likely you are to make those discoveries. It's complex to derive all the value from this data, though, right? The more data we're bringing, the more complex types of data, the different areas and domains of data that we're bringing. This ends up being very complex and time-consuming and costly to derive value. However, it's important. The key is that you can integrate all of your diverse data sets, your large volumes of data, with everyday data so that you can get biological, meaningful results. You need to be able to combine everything together to power your scientific discovery. So multimodal data is obviously urgent and important if we're talking about the values that it can bring, and we're talking about how you can derive different data sets and you can gain different scientific insights from your data sets. This is obviously something very important, but we understand that it's hard to use. It's challenging. This is why that there's a lot of pain out in the market. We did a survey, specifically also when we were at a conference in Biotech X in Basel. We had a large amount of people fill out a survey, and we found that 6.8% out of 10, 6.8 out of 10 people said that multimodal data was urgent and important. So it's a huge amount of folks that find that the multimodal data is critical to the work that they're doing. 42% of this said that it needs a lot of engineering resources, though, to take advantage of this. So it's very complex, and it takes a lot of effort to take advantage of this information. 28% said that the data volumes were high and they're unable to move it around and collaborate easily because of the size of the data. So they've got this massive volume of data. It's hard to use. It's super important, but you can't really collaborate on it. You don't have the ability to work with other coworkers. You're working in your silos. If you're in your silo and you're in your area, your coworkers can deal with things. When you try to get outside of your domain, you're outside of your area, collaborate with different organizations across different continents, it becomes incredibly difficult for folks to deal with. And again, 25% said that the collaboration is just completely broken between the bench scientists and the computational teams. So even across the pipeline of your analysis, where you're trying to run your analysis, hand them off to the next team to derive further business and scientific insights, that process is broken. So it's difficult to collaborate across, and it's difficult to collaborate up and down the analysis pipeline. So we hear from a lot of folks in the ecosystem that these challenges are real and they're causing direct impact into everyday use cases that people have in trying to bring the value. So these are insights that we've gleaned by taking a survey, again, at conferences, at the market at large, to a lot of different domain users. And we'll talk about some of those domain users as we go. But to get started with, we wanted to ask a question to the audience here today and ask, what are your primary challenges that you're facing in your organization to deploy the relevant data, including the multimodal data aspects with your R&D process? So we'd love to get your feedback right now. Just a real quick survey. We'll take a minute or two here. We'll get a couple answers. And then we can talk a little bit more about the challenges that you're seeing and how that you can effectively look at purchasing and dealing with software based off this. So there's several different aspects that we've seen users talk about when we talk about primary challenges. We talked about some of our largest survey items just a moment ago, where multimodal data is complex and it takes a lot of work to deal with and engineering resources to handle. But there's also other aspects around inefficiencies, right? Do existing solutions not scale as well as they should? Are you not able to reach the volume of data and the scientific analysis because either it costs too much or it can't handle what you're looking for? We've also heard from other folks that data that's coming from instruments and associated with the software of those instruments, they get locked in. So your vendor locked into instrument-specific software, and you really can't maximize your R&D because your files are in proprietary formats. You're not able to move those files around. Perhaps that's a challenge you face based off the type of labs and software and hardware that you're deploying out, where you are affected by that lock-in between the vendors. We've also seen a number of folks talk about their struggles with fair data and being able to have single source of truth for their data sets. Are you struggling with how to approach fair aspects? This is something else that we will cover in this talk a little bit later, but we'd love to hear how important fair data is with you and the type of challenges that you're facing around that. Okay, it looks like we do have some survey results here, and I see that majority of folks, as indicated by our larger polling in the community, says that multimodal data being complex and requiring a lot of integration needs and engineering resources for those integrations. 83% of the folks on this webinar have said that that's the single largest challenge. That's followed up by, of course, the existing solutions don't scale well. Complex data comes with scale challenges typically. So we got 67%, so about 2/3 of you said that the existing solutions don't scale well. which makes sense. It's why you're here in this talk to figure out how we can purchase new software and we can evaluate software to make sure that we can actually take advantage of all of this data sets. And about 2/3 of you also said that you have problems associated with vendor lock-in in your software, that whether it's your ELNs or your LIMS systems or your instrument software are not allowing you to maximize the value because you can't get the data out and you can't expand upon your data sets there. So that's also quite a large folks that are looking for ways to get out of that type of lock-in scenario where you just can't scale to what you're looking for. It also seems like several folks are having some problems with fair data. So like I said, we'll talk a little bit about that. 2/3 of you also said that you have problems handling fair data and worrying about single source of truth, which goes directly with also 2/3 of you said you have problems with collaboration in here. So we're going to cover all of this as we go. And we're going to publish all of these poll results as part of our wider publications that we've been doing and continue to do as we get this feedback and collection from the wider ecosystem. Expect to see some upcoming releases, and we'll talk some more about that at the end of the webinar here. All right, so based off what you guys were just saying, I think we all here agree that the current approaches that people are taking to deal with this struggle. There's a lot of challenges associated with trying to have a multi-omics and a multimodal platform that scales and lets you bring the insights and business value that you need. We've seen basically two approaches to the current software that people are deploying out for this. One is general purpose solutions. So folks that try to take general purpose software like Databricks or Snowflake, which work well for some cases, they're general purpose, but they try to fit these complex modalities to them. They try to fit genomics data or single cell data or images into these generic systems. They try to have special purpose files that have semantic meanings to stuff them into these systems. Some aspects can work. Databricks can handle some files. You can put an image in Snowflake, but if you put an image in Snowflake, you're not going to be able to slice it. You can't query it, and you're certainly not putting terabytes of images in Snowflake. If you have arbitrary files in Databricks, you can access a file, but there's no semantic meaning behind it. You end up having to build layers and layers and layers on top of the ecosystem here to handle these general purpose solutions, which leads a lot of folks to the other side, which is bespoke scientific solutions, right? Looking at solutions that are geared toward one of these complex data models that allow you to hone in on either genomics or imaging. But they often have problems that they're not built for scale, right? And they're bespoke solutions. They emphasize a lot on the web interface or other visual interfaces, but they sacrifice performance. They sacrifice scalability, and they sacrifice the ability to handle diverse data sets. They work really well for one specific modality, but they don't work across the board. And this leads to a massive gap. You've got general purpose solutions where you can try to force everything in, but it doesn't work. It doesn't scale. You don't have the semantic meaning that you need there, and you can't actually operate on the data you're trying to access. And then you have bespoke scientific solutions where you end up with domain-specific tools that still can't scale and can't handle what you're looking for. All of this complicates your data infrastructure, and it means that the collaboration between your different teams suffers because you've got multiple solutions being deployed out. None of them really solve your complex problems that you have across the board, and you end up dealing with challenges that you're suffering with. How can you actually handle all of these diverse data sets? A lot of the different tools and the struggles stem from the fact that inside of an organization, you have different needs, although they're shared interest. These different needs often are seen as competing and drive data silos in different platforms. The different needs stem from folks like heads of infrastructure, where you're trying to build a whole solution that will encompass off-the-shelf software that will provide scalable and integrate with other ecosystem tools. You're looking for generic software that works really well. Then you have data teams and AIs that they want fair data. They want all the data as much as they can get, and they need it harmonized. They need scalable solutions, but their scale, they're focused on data and AI, is a little bit different than the scale of the infrastructure teams, right? And they're looking specifically for different computational tools, right? They want scalable GPUs. They want to run large machine learning workflows. They're looking for certain types of aspects. And they need to ensure security and compliance because they need all the data they can get a hold of, but they've got to make sure that they're dealing with consent management and they're dealing with all the compliance and regulations that are associated here. And then you've got research scientists, the folks that are actually trying to do the science, right? The folks that want access to their data, they want access to diverse data sets, but they are really looking for user-friendly interfaces and the functionality that they're getting. They care less about off the shelf. They care less about scalable. They care about getting their job done. Can they actually work and perform the research they're trying to do? And they need rich visualization capabilities to derive these type of insights. So these teams have different needs, but they end up with shared interests across the board, right? They're looking to accelerate their data process. They want to streamline cross-function collaboration because all three of these groups are trying to work together, right? And they need to speed the time to insights. Everybody is trying to get their data and deliver it faster. These shared interests mean that there can actually be a common set of tools and a common requirements that can satisfy all parties in an organization. And this is where building a multimodal data platform comes in. So the building blocks for a multimodal data platform, we've heard from many folks in the community and many folks in the industry about what it means to build out a multimodal data platform. So here we've got one individual from a top pharmaceutical company that's a therapeutics lead, and you can just read the quote, but the first sentence really kind of nails it here, right? In an ideal world, we would have a data type agnostic platform that would be able to ingest data sets from different sources, right? They are trying to bring the multimodal aspects together in a single platform, right? Bring it in a way where you can handle all of your data together. So with the shared interest in mind, with the need to build out this multimodal data platform, we have come up with a set of building blocks that you can use to look at for building out this type of multimodal platform. The building blocks include being able to have a catalog, being able to collaborate, and being able to analyze. Three foundational items, right? You have to catalog all of your data sets. Where is your data? Is the data catalog, is it a fair data catalog? Does it have the discipline that you need for collaboration to meet compliance and regulations? Do you have the expertise of scientific solutions built into this catalog, right? Having a list of files doesn't help unless you understand what the files actually are for, right? You need the generality of the file manager, but you've got to have more details about it, right? You need to understand what are the semantics of this data that I'm looking at? Where did it come from? What's the lineage of the data? You have to have more than just a file manager, but you need to support those arbitrary files. You need the generality of that. And of course, all of this builds upon the needs of having a power of a database where you can perform this type of cataloging and analyzation at scale, right? Can you streamline this cross-function? Can you speed your time to insights? And can you accelerate the data process? People bring databases in to help with all of this, right? So you need a platform that you can handle these four different areas to help accelerate the cataloging, collaboration, and the analysis at scale. And so with these building blocks in mind, we've come up with evaluation criteria for how you can evaluate a multimodal platform where you can handle your frontier data. This is your multimodal data sets that are complex, and your everyday data, the arbitrary files, the Excel spreadsheets, the PowerPoints, the documents where you have produced everything. So we've come up with four basic areas to ask questions on, and we're going to dive into each one of these with a series of questions. But the evaluation criteria, first, it starts with, can you centralize your data sets in your catalog? Centralization means, is everybody in your organization able to look, see, and touch and access the data that they have permissions for, of course. Access and governance is important in this. But you need a centralized place to be able to look for the data, find the data, and have that catalog aspects. Can you collaborate securely? If you can find the data, can you share the data with others? Can others come in and find the data? And can you do this in a way that meets all of the compliance regulations, all of your governance that you need internally, and any geographic rules and regulations that apply with multinational organizations? And can you analyze with ease? Every time we talk about security, folks always say, is security going to get in the way of the analysis? It's incredibly important that the multimodal platform you choose allows you to analyze at scale. And we'll dive into this in just a moment. And lastly, is the scale economical, right? You need to be able to do this fast and efficient. And we'll talk about some ways to determine if your platform will scale economically as we go here. So let's talk about centralizing your catalog and having one place and one platform for everyone to come in and work for. So what should you look for when you're trying to look at a multimodal platform if it can handle this type of cataloging that you need? The first is, does it store all modalities, including descriptions and metadata, right? Metadata is extremely important for data itself. It's almost more important than the data is the metadata around this. And does the platform that you're looking at, does it handle all of these modalities? And does it handle the metadata associated with these modalities? And do you have things like descriptions, tags, all the advanced functionality you need to be able to have an effective catalog? How does this handle the data of the future, right? We see that a large amount of folks struggle with their platforms and the data because what they need today is not what they need in 5 years. And we hear this back from the community and again the industry at large, where we have folks that have expressed that a big pain point they have is that they deploy out software. They spend a lot of time and effort building it into their workflows and process. Then the needs of the business change. New science is discovered, new modalities are brought in, but there's too much inertia. They can't change. They can't bring this new data sets into their existing platform because it wasn't designed for that. So it's incredibly important to ask, can you handle data of the future? Will you be able to handle what you need in 5 years, in 10 years? If drug discovery takes 10 plus years, you need to be thinking long term, and you need a platform that's going to be flexible for this. Does it handle and offer interoperability between formats and content? You need to be able to interpret and understand what this data actually is. A file is not a raw file. A file has meaning. There's data inside of that file. Can your platform understand that that file has meaning to it? Can you expose that meaning to users so that they can understand, is this the data that I'm looking for? And does it provide keyword search, right? Can you look for advanced search across all of your data sets based off the modalities, the tags, the descriptions that you have, the metadata? Can you perform search that's global across your entire organization's data sets? Everything in the company should be at users' fingertips. Again, with permissions and governance and access control baked into the platform so that what's at their fingertips is everything that they have access to. So handling the catalog leads directly into collaborating, right? Once you have a catalog, you need to be able to ask, can the system support more users accessing this data as I grow my organization, as we bring new modalities in, as we want to bring different data sets together? Can I eliminate the silos so that two different labs can talk to each other and share data, and we can have bench scientists running large-scale analysis on multimodal data sets? The first and most important aspect is, do these folks come to one place, right? Can everybody log into the same system? As soon as you start having different systems for different user groups, and as soon as you start saying, well, the needs are different, and you break apart those shared interests, you lose. You lose because you have data silos, you have complexity that comes in, and you're not able to achieve the efficiencies you're looking for. And we've heard this from industry partners in the area. Again, in therapeutics, we see that the bioinformatics teams, they can be booked for weeks on end, right? And they're looking at major bottlenecks. But part of this is because the teams can't work together. The bioinformaticians are in one place. They have access to certain sets of data. The scientists are in a different place. A scientist can't come in and tweak a query. They have to go back to the bioinformatician, wait several weeks just to make one parameter change, right? The scientists need to have access to be able to work with the data directly. And working with the data, it might be programmatic, it might be through visualizations, it might be through workflows, but they need access to be able to quickly experiment and quickly run their data and understand and be in the same place as the machine learning teams, as the data scientist teams, as the bioinformatician teams. So This also leads to the question of, can you collaborate on federated data without moving it, right? If you have a centralized catalog, it's important to understand, though, that having the catalog centralized doesn't mean the data has to be centralized. The data is going to live in different areas. You're going to need to be compliant with geographic restrictions. You're going to have data physically stored in certain areas based off the laws and governance requirements of that. So can you collaborate without having to physically move data? Can the data live in different places, but can everybody see the data? Can they access the data? And can they run analysis on the data without having to copy it, without having to download it to your laptop, without having to send it over email, keeping one source of truth and being fair compliant? We hear this from the industry also, right? That federation is incredibly important, and that one of the major scaling pains is handling the data and data movement, right? As soon as you have image files that are terabytes in size, as soon as you have Atlas scale data sets, as soon as you have biobank scale data sets, no longer can a scientist download it to their laptop. First off, you don't want anyone downloading things to the laptop anyway from a compliance standpoint, but we know it happens today. But at scale, it's impossible to happen. You need to be able to federate the questions to the environments where the data is so that you can minimize that movement and achieve the secure collaboration and the secure analysis. Does it offer access control and logging? Right? When we talk about security, we mean integrations into single sign-on providers, integrations into consent management systems, integrations into the variety of different access control systems that exist. And is all of this logged in a way where you have full compliance and governance of this data? And how is this platform manage the data governance? Access control and logging is great, but you need to understand, how does the data governance be managed to the platform? Does it integrate with existing systems that your organization has published out around, again, single sign-on providers, compliance, and consent frameworks? We hear again from the ecosystem that it's incredibly important that you have this type of data management and governance, and that you have the compliance regulations around things, and that you can track and you have audit capabilities to understand every component of the pipeline, who touched the data when, what did they do with the data. You need the lineage of any changes in any access so you understand everything that's been happened, and you can start thinking about reproducibility. Once you have auditability, then you can have reproducibility. And reproducibility leads us directly to FAIR principles, right? Is the data set fair? Does the data platform facilitate your data sets being fair? Does the platform itself handle FAIR principles at its core foundation? FAIR is something that everybody we talk to finds very important. We've got a head of data science here that we've talked to who felt that the FAIR aspects were very critical to handling the data, and that being able to have a consistent data sets and contracts in place to enforce FAIR was critical to growing and scaling. The last aspect, of course, is the data platform and your vendors compliant? Do they have SOC 2 Type 2 compliance? Are they HIPAA compliance? Are they GDPR compliance? Are they CCA compliant? You need to make sure that they have all of their different compliant certifications, both as vendors and their organizations, so that you can trust the organizations that you're going to be working with. But also, is the software designed and built for this? Does the software account for all the different permutations that you have in the regulations, but that are both from national bodies and supranational bodies that you have to meet? And can you handle the diverse types of compliance inside your own organization, right? A lot of folks have data that lives in different geographic regions. You need to be able to understand where the data is, the compliance aspects of that data, where the user is physically located, and what they are allowed or not allowed to do. And that's got to be baked into the platform. Now, once you can understand that you have the catalog and you have collaboration, the next step is doing the actual analysis, right? Once you find the data and you can access the data, you have to perform your analysis, and you have to understand the insights and derive your insights from discovery. So questions to ask and questions to look at. Does the solution offer programmatic access for data wrangling? Visualizations are important, but you also need to have programmatic access, ideally in a variety of programming languages and APIs, so that your scientists, your bioinformaticians, your machine learning folks, all the different user groups can actually support using the platform, how they're trying to do it. Can you run ML workflows and ML pipelines? Can you access bioinformatic tools? Do you have the ability to do this all in one platform? Do you have notebooks for data scientists, right? You need a interactive exploration platform where folks can come in and they can work. Notebooks are incredibly popular for this, right? People like to come in with a notebook. They like to understand what is happening with a notebook, share and collaborate with other users, see the outputs of a notebook, and then modify and run those notebooks live. Do you have flexibility for dashboards, for visualizations, right? Programmatic access is great. Data exploration in notebooks is fantastic. But a lot of folks want to have that visual experience, right? And do you have flexibility to build these dashboards into the platform? Can the platform run the dashboard? Does the platform integrate dashboards in a way where compliance and single sign-on is used, where you can understand the collaboration aspects we just talked about that are built directly into the platform? So not only is it about who accesses the platform, but it's about, can they access the data used by the platform? And does TileDB handle all of that? Does the platform handle all of that for you directly here in the system? And of course, does it integrate with popular tools, right? Folks need to understand when they're doing analysis that there's a set of tools and APIs that people like to use, packages that are ever changing, right? What's popular today will not be popular a year from now or 5 years from now. There's an ever-changing list of tools in the AI ecosystem, in the machine learning ecosystem, in the bioinformatic and life science ecosystem. And can the platform that you have interoperate with these different tools and frameworks that people like to use? Are LLMs and copilots integrated into this platform? Do you have a way to handle Gen AI in this platform? Will it scale to where we're going in this AI ecosystem where we're ever evolving? And do you have the ability to do vectors, or do you need a separate vector database? Can you have ML models integrated directly? Running AI and ML and LLMs and vectors are critical to where the future is going, where we are now and where we're going in the future. And does the platform you have integrate this, or are you going to have to bring in another vendor and another tool set to handle all of this? Again, we've heard from folks in the community that they want this flexibility of the analysis. Folks don't want to just access a data lake directly. They're not trying to just come in and access raw data, right? They want interactive experiences, interactive via notebooks. They want to offer different libraries and integrations. They want to have different dashboards that can be run, that they can build for other folks that come in the system. People are looking for a platform that's all inclusive, that includes the copilots and the LLMs that people are still exploring and seeing and understanding how they will help augment the science and the work that's being done. And they want to know that the platform that they're going to select is going to continue to move and evolve as the AI ecosystem continues to evolve very rapidly over the next few years. And if you're running analysis at scale, you need to know, is it economical, right? Once folks start accessing all the different data sets and you've unblocked your entire organization's data for different users, is it going to be economical? Are they going to be able to understand that they can run these science experiments without fear? And the first question you have to ask is, what tools and methodologies is this platform using to scale data, right? Based off the methodologies, you'll understand, is this actually going to scale to the volume of data that we have today? And is it going to scale to the volume of data we have in 5 years and in 10 years? Is it going to achieve the level of performance that we're looking for? Can you afford to run multiple experiments concurrently? Another thing that we've heard from the community at large is that often they run a single experiment at a time. The cost of running the experiments is too large. It's too time consuming and it's too expensive. They can't afford to spin up 5, 6, 7 experiments concurrently. And instead they run them serially with iterative approaches. But they're trading computational time for scientists and engineering time, right? They run a job, they come back tomorrow. They run a job, they come back tomorrow. Instead of rapidly iterating, they're actually spending a significant amount of time, and they're actually costing your organization more money because you're paying for folks to wait and do things serially, right? So you need a platform where you can run multiple experiments concurrently, very fast, very efficient. And this leads to the question, is it cloud native, right? Is it designed for the cloud native approaches of today? Is it elastic? Can you handle running your data sets at scale? Can you run your analysis at scale? And is it elastic so that when the jobs are finished, it scales down? When you need a GPU, you get a GPU. When a GPU is not needed, you shut the GPU down. Can you be effective and efficient with your elasticity? And is it designed for this cloud native architectures with the separation of storage, separation of compute, and elastic nature here? A lot of folks look for ways of scaling their data around this, right? And trying to understand, can you scale the data and can you scale the compute? If you can scale the data and you can scale the compute, then you can be effective in your research. And you can be effective in your organization, and you can actually derive insights and value and cut down on that time of 10 to 15 years for drug discovery and try to make that 5. So with these questions in mind, and with looking at these 4 pillars, we have developed a reference architecture that encompasses all aspects of a multimodal and multi-omics data platform. You have, in this reference architecture, you have external data sources. These external data sources are going to live either in the cloud or physically on-prem. They could be instruments where the data is being produced. They could be labs that you're dealing with. They could be public data sets that exist out there that you're trying to bring in. And the important aspect is with these data sources, you need to bring them into the platform. They've got to be cataloged. They've got to be indexed. You've got to bring and ingest them into this reference architecture and platform so that you can understand where this is. This platform needs to be built in a scalable, cloud native way, right? For our reference architecture, we picked using Kubernetes, a standard in the cloud ecosystem for building scalable architectures, as a foundational layer for how you're going to build out this infrastructure. So you have a Kubernetes deployment that's elastic, that allows you to scale different resources and allows you to deploy the platform on top of this basic architecture. But being cloud native, it's important to understand that cloud native doesn't mean this only runs on cloud environments like Amazon or Azure. Being cloud native is meaning how the architecture is designed. This same deployment model should work for physical data centers and on-prem deployments too. There's a lot of folks in the community and a lot of folks in the ecosystem that have physical footprints. You have data centers that exist out there. You have infrastructure that exists. You should be able to deploy the platform in that existing infrastructure, still achieve your level of scalability and your elasticity, and have that deployed out. And it's important to understand that in this reference architecture, you need to be able to have your storage separated from your compute infrastructure. You'll see here that we have storage being an object store, located or other centralized storage, could be distributed file systems that you might have. But this is separated out from the Kubernetes cluster. Storage is not attached directly there. This allows you to effectively scale your compute separately from your storage. This type of reference architecture gives you that scale without the fear of cost. As your storage grows, you don't have to worry about growing your compute unless you have compute jobs that require that. Similarly, you don't have to grow your storage just because you want to run large machine learning workflows for a few days at a time. This reference architecture builds upon the building blocks that we talked about and gives you the foundations for understanding how you can look at different ecosystems, different tools, and put them all together to decide on a platform that's going to give you the scalability that you need. So we'd like to pause now and ask our second poll of this webinar. And we want to know, where are you in your journey for a multimodal data platform? As we talked about at the beginning, it is budget season. And a lot of folks are looking at their 2025 budgets and they're planning what software they want to have in 2025. So we'd like to understand where you are in your multimodal data platform. Maybe you don't need a platform at all. But being that you're on this webinar, I assume that you probably do need a platform. So we'd like to understand, are you actively looking for one? Do you already have a solution that doesn't meet your needs and you're looking to replace it? Are you working on a do-it-yourself solution because you didn't find a vendor or software that met all of your requirements? We'd like to understand where you are, because as you can imagine, the next few slides, we're going to talk a little bit about how we see this reference architecture being deployed out, and how we see the aspects of this reference architecture being used even in our own software here at TileDB, and how TileDB can help you with some of these aspects. We found that a lot of folks in the ecosystem are in the middle of their multimodal data journey. They have folks that they've understood that the software they have today is not quite up to par with what they need. We see the same results here in the survey. About 40% of you said that you don't have a multimodal data platform, but you're investigating because you realize you need one. And about 20% of you said that you're actively looking for a solution today, and you're in the middle of checking that out. So about 60% of you are looking for solutions. Another 20% of you, interestingly enough, said that you've got a DIY infrastructure, so you've done it yourself. This is also something we hear commonly, that folks over the last few years, as they've found the need for multimodal, they've started trying to fill the gap between those general purpose solutions and the bespoke solutions by throwing engineering resources at it and building on top of solutions in-house. All right, so let's talk a little bit about TileDB for a moment here. So as we look at the reference architecture, TileDB has been designed and built from the ground up to achieve this multimodal research and development platform that we've been talking about. We have the foundations built directly in around catalog, collaborate, and analyze. We have understood through our work in the community, through our work with academics, and through our work with industry partners, all the different aspects here that are required. ETL, support pipelines, data warehousing, being AI native, supporting the unstructured data along with the scientific data, bringing in the arbitrary files and everyday data sets that you have, and of course, being able to understand and run specialized applications like notebooks, like dashboards, arbitrary web apps, and handling that multimodal aspects where you can actually bring insights directly into this data itself. And TileDB has built this based off an architecture where we separated out the storage layer, right? And we want to have different types of storage, whether it's object storage like Amazon S3 are most popular, or it could be on-prem solutions like using MinIO or Lustre. The storage can scale independently of your compute. At the compute layer, we have a lot of domain-specific applications for interoperability, right? We want you to be able to use the tools that you expect to use in the languages that you expect. APIs in 8 different languages, machine learning integrations with things like TensorFlow, with ScanPy. We have domain-specific integrations with like ScanPy. You have OME integrations. You have integrations into Seurat. All of these integrations in life sciences and general integrations for ML and APIs give you the flexibility of running your analysis on top of TileDB. And the core aspects of TileDB are a whole platform where you have the access control, the logging. You have serverless compute, serverless SQL support, serverless user-defined functions and task graphs, so you can run entire workflows in a serverless nature. The notebooks where you can have Jupyter running, do exploration, do analysis, and share and collaborate with other users. Share your notebook, share your analysis in the same platform. You have rapid performance and scalable performance for reads and writes, concurrency, multi-reader, multi-writer setup, so that you can achieve what you're looking for in a columnar cloud optimized format. And of course, when we talk about lineage, we talk about audit trails. TileDB has built-in support for data versioning and time traveling. So not only do we have audit trails on users and what they're doing, but the data itself has versioning built in, so you can understand the entire lineage here. And that works across the system. All of these components work together in the platform. So whether you're using imaging, whether you're using SQL queries, whether you're using tabular data sets, whether you're running with machine learning workflows, all of these features work across the board. And it also doesn't matter where you deploy this out. It could be running on Amazon. It could be running on your own data centers on-prem. You could have storage that's MinIO. You could have storage that's Lustre. All of this is supported so that you can build this platform, deploy it out, and meet the needs of your organization, no matter what they are. And we see a lot of use cases for this type of platform in life sciences, specifically focusing a lot on 3 aspects in life sciences. Population genomics, where we have a powerful variant store where you can bring in your data, store it at biobank scale, and perform your analysis, do GWAS, do entire clinical diagnoses directly in the platform. And we'll talk in just a moment about a real-world use case around population genomics, one of our case studies. Single cell analysis, where you can have atlas scale data. you'll notice that all of our different modalities of data we talk about, we've designed for scale, right? Whether it's biobank scale or Atlas scale, we support bringing massive amounts of data into the platform and supporting this in a way like no others can do, where you still have the governance and access control. And we work directly in the community and in these ecosystems. So for single cell, we actually have a whole collaboration with Chan Zuckerberg around defining data models and defining the SOMA project, where they've stored their entire corpus of data, now over 100 million cells in the Chan Zuckerberg cell by gene atlas, 100 million cells stored in TileDB, available in our platform. And then on biomedical imaging, right, you can work with massive scale microscopy data or other types of biomedical imaging. And we have native AI and ML integrations, right? So you bring your images in, you can run object detection on those images. You can do ROI queries directly on those images. We've got ML frameworks that work off the shelf. And we have vector search capabilities for everything we just talked about, which means that with things like images, you can bring an image in and you can say, show me similar images in the entire catalog. And guess what? You can do the same thing with single cell analysis, right? Our integrations extend everywhere. So with single cell, if you have a cell of interest, you can say, in my entire catalog, show me all cells that look like this cell. Similarly on PopGen, if you want to do like kinship analysis, you can say, hey, I've got a particular set of variants. Show me anybody that's got similar variants, or show me any patient that is similar to this patient. So TileDB extends our catalog functionality, our search functionality, our vector search, AI, and ML integrations across all of the vertical integrations that we have, so that you can have semantic meaning across the board here, but all in one platform, so that you can do this at scale. And all of this asks the question of why focus on these foundational items of a data platform, right? The end scientists are performing actual science. You're doing research and development. Why do you need to focus on building out this multimodal platform and deploying a multimodal platform? Well, we've got a couple insights that we've seen from the community here and from partners in industry. The first is time to insights, right? You need to democratize your data so that you can have more folks accessing the data sets inside your organization, and you can lead to faster insights. The more people touch the data, the faster you're going to get insights. And all of this at unprecedented speed, right? You need a cutting edge database and a platform where you can have speed and scale, of course, being economical. And you need to do this all with less engineering required, right? Your platform needs to have the different integrations, the different visualization tools, the different governance and compliance, so that you need to spend less time on building on top of the platform and more time doing the science that you're trying to achieve. And you need to simplify your entire infrastructure. So simplifying the infrastructure here means that you can deploy at one platform instead of 10 different platforms. You don't have 10 different data silos. You can have all of your data shareable across the entire organization. You can reduce the amount of DevOps that you need, the amount of infrastructure teams that are required to run things. And you can focus instead on enabling the actual scientists and bioinformaticians to deliver on what they're looking for. And of course, all of this needs to be done much more economically than it is today, right? If you're going to achieve the scale that you're looking for, you need to do this in a way that's economical, where you can run multiple experiments concurrently, fast and efficient. Okay, so let's talk about a couple use cases that we have where we've actually seen this deployed out for folks, building out multi-omics and multimodal platforms where they can actually achieve success. So one of our first examples is Phenomic AI. They're targeting drug discovery for cancer, and they're specifically applying a large amount of ML to single cell data sets at unprecedented scale. The original challenge that they had was scaling, right? They wanted to bring the single cell data, which has many different components to it. It's a very diverse data sets that they have, and they're trying to build an atlas, and they're trying to run ML on top of this atlas that they have. They were not able to do it originally. And the solution is they've brought in TileDB. They have efficient out-of-core computations. They have efficient machine learning integrations. They have fast access to the data. They have compliance and access control to the data sets. And they have semantic meaning around the data. It's not just raw files. These single-cell atlases that they're building have actual meaning behind them. And the outcome of this is that they've launched an entire platform that they're able to support with this large-scale data, where they can do expression profiles and explore for targeted discovery. This is in production right now. They're seeing massive success with this, and we're very, very happy with the outcome that they've had by bringing in TileDB to support this multimodal data sets they have around single cell and the complexities they have there. Another great example is Quest Diagnostics, a customer of ours who was looking for an enterprise-wide multi-omics data platform. They wanted to drive AI in their organization. They wanted to bring in something that could handle the diverse data sets that they have. Being a diagnostics company, they're producing massive amounts of data. They have a large amount of labs. They're geographically diverse, and they're international. So they needed something that could come in and handle all the different regulations and compliance rules that they had, but could also achieve the scale and efficiencies they were looking for. So they had several challenges in their organization. One, delivering genomics ready data was a challenge. Again, they have many different labs and many different data sets being produced by different organizational units. And they were not unified and they were siloed. They were not able to ingest and store the scale of data they were looking for. They had these data silos. More data was being produced. They're looking to do up to 6 million samples a year on average. But they need that in a analysis-ready form that folks can access. Scientists and researchers can't go to 15 different labs and try to access data. They need that in a centralized place where it's stored in an efficient and scalable way. And of course, compliance is a huge problem with the geographic diversity that they have and the consent management that they have across the board. The solution was using TileDB, bringing TileDB into to this, where they've seen a massive reduction in the storage costs, about 26% storage cost savings, so efficiency achieved. They've solved the N+1 problem. They're able to add these samples continuously to their data sets. They don't have the same type of problem as they stored with arbitrary files. And the cost has gone down drastically also for the computations, right? It costs them less than a penny a sample to bring it in, and they're able to do over 24,000 samples a day, limited based off their labs, not based off the technology. It's a huge switch from where they were before, where they were technology limited. Both Quest and Phenomic, Ray at Quest, a great partner of ours, and Sam at Phenomic, a great partner of ours. We've got case studies out for these. We'll send them as part of the follow-up to this webinar, but you can read more about the specifics that they have, how they've deployed out this multimodal platforms in their respective companies, and the advantages that they've seen there. So with that, I'm going to go ahead and turn it over for Q&A. I know we're running a little bit low on time, but we do want to answer some of those questions that have come in. So Devika, I turn it over to you for Q&A.
Yep. Thank you, Seth. That was really nice. I have one question from Santha Ramakrishnan. So you may have covered this, but what makes you different from any other data platform like Databricks or Snowflake?
Yeah, great question here. So the main differentiator we have here at TileDB is that we bring all of these diverse data sets together, and we store this data in a way that allows us to bring insights into the data. So inside TileDB, in the platform, you've got the ability to store raw files, but you also have the ability to bring structure and semantics to these files. So a BAM file can be recognized as a BAM file and have meaning to it. But also, when you have things like variant data, like VCF files or single cell data or imaging files, TIFF files, SVS files, etc., TileDB can actually structure this data in a much more effective way. So you can keep your file. In some cases, it makes sense to have these things represented as arbitrary files. But TileDB actually allows you to convert them into a better format. TileDB has a format that we built, which is built on top of arrays. And actually I have a slide for this here, where we can actually convert population genomic data into a three-dimensional array, a single cell data into a matrix here, or biomedical imaging into like a dense array. And because we have the ability to have the raw files, but we also have the ability to shape and store these files in a very fast and efficient way as we model them with arrays that have data and metadata associated with them. This allows us to differentiate from existing solutions out there, which can't actually effectively model the data. There are solutions that can perform some cataloging on files, but they don't usually bring semantics to those files. And then once your data set grows beyond the scale of files, once you have biobank scale data and you have 500,000 VCF files, it's no longer efficient to have 500,000 VCF files. It's not efficient to have biomedical images that are multi-terabytes in size, where your entire data set and catalog is petabytes or exabytes in size. TileDB gives you the ability to have those files, but then also, when required, when you need performance and scalability because you've outgrown files, to convert them into our array structure. And in this array structure that we have the integrations. So when you're talking about like single cell data, you can use ScanPy, you can use Seurat. Your bioinformaticians can use the visualization software that they expect to use and the libraries that they expect to use on top of our arrays. We've built out an ecosystem around this and the integrations so that you can work like you work today, and then you can scale in an unprecedented way.
There is another question. What challenges have you seen with your customers trying to purchase an R&D platform?
Yeah, this is a great question here. So we've seen a number of challenges, especially as they try to bring a multimodal platform into an organization. First and foremost, security and compliance is always a challenge, right? We've built TileDB from the ground up to meet all of the security requirements. We have SOC 2 Type 2 compliant. We're HIPAA compliant. We're GDPR compliant. We have all of the attestations for that. We pass all of the security reviews that people put out there, and we do external audits to all of that too. However, that doesn't change the institutional struggles that exist around compliance and around ensuring that data can come in. A lot of times, organizations have said, we're going to put data silos up as a way of achieving compliance. The data doesn't leave the wet lab. Fantastic. Great. You are GDPR compliant. You are compliant with other regulations. The downside, nobody can actually do anything with the data, right? Security and compliance has become a barrier for scientific discovery. So helping folks understand that they can migrate to a system that does this, breaking down those barriers, enabling them to bring the data sets in. Another challenge that we've seen is once you start understanding to bring the data sets in and catalog and centralize this, it's being able to effectively share and collaborate across organizations. People have had data silos for decades, right? All of a sudden, when you get access to everything, you need to be able to efficiently find the data you're looking for and scale the data you're looking for. And this means that you need to enforce and set up things like fair data practices, like ontologies that need to be standardized inside of an organization. Bringing a multimodal data platform usually unlocks and exposes a few other challenges that organizations have. Ontologies being a very large one, where very quickly you find that in your organization, there's 100 different groups that have all picked 100 different ontology setups, and they're incompatible with each other, right? So we offer a number of ways to help facilitate this, and we try to enable people to convert ontologies, to do mappings on the fly, so you don't have to physically change data sets, but you can do query time mapping of ontologies. But we've seen a lot of folks that when they bring this type of thing in, it starts exposing more and more difficulties in organizations that drive people to try to better the entire organization that they have and better the data that they're bringing in so that they can really derive the science much quicker.
Thank you. I think we are almost out of time. Just one last question. What is the level of manual work involved in getting data into your platforms and accessible?
Yeah, great question. So in bringing data in, as I mentioned when we were the first question that was asked about what one of our differentiators is, TileDB can catalog existing data sets, right? When you have data that's stored in files, that's stored on an object store, stored in your centralized storage, we have the ability to catalog that information. So you can come in and you can bring BAM files and CRAM files and FASTQ files and image things into the system today, and you can access them through the system. But then we also offer the ability to migrate to more advanced data models, right, for that scalable compute. Bringing in existing data is just a matter of registering them in the system, pointing it at S3 buckets, uploading files if you're uploading them from other systems, from LIMS or what have you. But if they exist on some sort of centralized storage that can be accessed, you can point the system at the storage and you can access what you're looking for. The conversion process, once you say, hey, this is great, but I've got 500,000 VCF files, I want to put it in the TileDB format to achieve scale, we offer automation around all of that. So we have point and click interfaces in our web interface that guide you through this. We have one-line programmatic APIs that can say, point me at these VCF files and we'll convert them for you automatically. So we have a lot of automation around that to facilitate. But the most important aspect to understand is that On day one, you can bring your files in the platform to get the catalog, the governance, the shared, the access control, the dashboards, the notebooks, and you can do that on day one. And then, as you get all of your data cataloged, you can then start worrying about any conversion process to achieve scale that you might want to do.
All right. Thank you, Seth. Um, that was a really nice session, and thank you everyone for attending. If you could please move on to the next slide, Seth, the last one. We do have another webinar coming in November 21st, where our partner Z4, Raghavi from Z4 and our own solutions architect Chad are going to be talking about building a fair data platform for genomics at a large pharma using TileDB. So please register. We look forward to seeing you there too. Thanks again, everyone, for joining. Thanks, Seth. And thank you, Maher, for coordinating everything behind the scenes. All right. Thanks, everybody.